Hello everyone, welcome to this session on the kinetics problem, and this we are going to solve by D-element principle. So before proceeding to the solution, we shall start to read the statement of the problem and then identify what is the unknown parameter that we are supposed to find out and what type of principle we need to adopt for the application of the inertia force. So here it is a problem related wherein it is a block of mass 50 kg. That is, mass of the block is 50 kg and it has been initially at rest. Initially at rest means initial velocity will be u0. So when it has been mentioned as rest, that means the body is not moving. So initial velocity will be 0, and which has been placed on a 20 degrees inclined plane with a coefficient of kinetic friction. That is, this is kinetic coefficient of friction as 0.25. Now what we need to do is we need to find out the distance and the time of the body travel before attaining a final speed of 15 meter per second. That means this is final velocity is 15 meter per second. So when the object attains, that is this particular block attains and final velocity of 15 meter per second, I need to find out how much is the distance traveled. That is, what is distance. S means the distance traveled, and which will be in terms of meters. And at the same time we need to find out the time of the body, that is t is equal to, and that particular t what we are going to calculate, it will be in terms of seconds. So these are the two unknown parameters that we are supposed to find out. Now before proceeding, initial velocity is taken as 0 because it has been mentioned as the body is at rest. Then final velocity has been considered as 15 meter per second because you are going to find out the distance and the time interval after at a initial final velocity of 15 meter per second, and distance traveled has been represented as s, and whose unit will be in terms of meter, and time interval whose unit will be in terms of second. So steps involved are, first we need to draw free body diagram. After that we have some protocols that we need to follow. So first rule is self-weight will be always vertically downward. Then normal reaction will be always perpendicular to the plane of contact. Frictional force will be always opposite to the moment of the body, irrespective whether the body is under the state of acceleration or under the state of retardation. Care needs to be taken that frictional force will be always opposite to the moment of the body. Then the last one is inertia force, which is very important now. This inertia force is represented as ME, and this ME direction is dependent upon the two categories. Whether we need to identify whether the body is under the state of acceleration or whether the body is under the state of retardation. If the body is under the state of acceleration, then inertia force will be opposite to the moment of the body. If it is under the state of retardation, it will be towards the moment of the body. Now, the similar type of problem we had solved in session 2, that is, or on session on kinetics, it has been subjected. Now there the initial velocity was been given, and we need to find out at what particular distance it will travel after it has been subjected to an initial velocity of 15 meter per second. Now here, during that particular session, the initial velocity was set and we are supposed to find out the final, that is the distance, and the final velocity would be 0. That particular condition was considered as a case of retardation. Now here, there was a decrement in the velocity from initial velocity of 15 meter per second to 0. That is, final velocity is 0. So this is nothing but a case of retardation, wherein initial velocity was 15 meter per second and eventually it reduces to 0. That means it's a case of retardation. But here the case is different. Here initial velocity is 0 and it gradually increased to 15 meter per second. So this is what is a case of acceleration, wherein the velocity is gradually increased. In the earlier case, the velocity gradually reduces, what we call it as the retardation. When the velocity gradually increases, we call it as a case of acceleration. So in case of acceleration, inertia force will be opposite to the moment of the body. To start with the free body diagram, we will separate this particular block, which has been placed on an inclined plane. After separation, the block will be represented in this particular fashion. Now here we need to show out the x and y direction for axis. To show x and y direction axis, the x and y direction axis needs to be shown along the movement of the body. Since the moment of the body is along the inclined plane, we will represent x and y axis along the inclined plane in this particular fashion. Now, self-weight is vertically downward. So self-weight we need to show it as vertically downward. Now self-weight here, mass of the body is 50 kg. Converting in terms of Newton, so it is 50 into 9.81. So self-weight will be taken as 50 into 9.81, which is W. Next, the direction of the normal reaction. That is, self-weight is vertically downward. Next one is direction of the normal reaction. Normal reaction direction will be perpendicular to the plane of contact. So it will be perpendicular to the plane of contact means it will be in the upward direction, which will make an inclination of 90 degrees. And that will be parallel to the inclined y-axis. So normal direction for reaction force component is over. Now frictional force. Now frictional force, as it has not been subjected to any external forces, which has been subjected on the inclined plane. So on its own, it will never move in the upward direction. Because due to gravitational attraction force, the body will always tend to move in the downward direction until unless it is compelled with an external force. Since it has not been subjected to any external force, so which indicates direction of impending motion is downward. That means the body tends to move in the downward direction. So if you literally want to move this particular body in the upward direction, an external agency force needs to be applied such a way that it moves against the moment of the gravity, so body will be subjected in the upward direction. Since it has been subjected on the inclined plane, placed on the inclined plane, there is no other option that the object has to move in the downward direction. On its own, it will never move in the upward direction. So direction of impending motion is downward, so which indicates frictional force will be in the upward direction. So frictional force relationship is, which is always mu times of n. And mu value is 0.25, so it is 0.25 times of n. Next, coming on to the last force, which is nothing but the inertia force. Now, as it is a case of acceleration, it has been decided based upon the velocity of the object. Initial velocity of the object was 0 and it gradually increased to 15 meter per second. So we considered it as a case of acceleration. So if it had to be in the reverse order, if the initial velocity was 15 meter per second and final velocity is 0, if v is greater than u, it is called as an acceleration. If v is less than u, it is called as a case of retardation. In case of acceleration, it will be opposite to the movement of the body. In case of retardation, it will be towards the movement of the body. Now, as it has been increased, gradually been increased from 0 to 15 meter per second, it's a case of an acceleration, so it will be opposite to the movement of the body. As the body moves downward, so inertia force will be in the upward direction, which is nothing but m into a. Now, m here, we need to take care that it is not in terms of Newton, it is in terms of kg. And kg, the mass of the object is 50 kg. So, here it will be represented as 50a. So, these are nothing but the values that we are going to show here now. Now, once we have noted down, here f of f is parallel to the inclined plane, that is, it is parallel to x-axis. MA is parallel to the inclined plane, that means it is parallel to x-axis. N, it is vertically upward, which means it is parallel to y-axis. Now, coming on to the direction of 50 into 9.81. Now, 50 into 9.81 is downward, so which indicates it needs to be resolved along horizontal plane and vertical plane. If it needs to be resolved along horizontal plane and vertical plane, inclination between here horizontal and inclined plane is 20 degrees. So this inclination shall also be 20 degrees. And self-weight is downward, that is W is downward. And we are going to resolve it along the parallel to the inclined plane and perpendicular to the inclined plane. If this has to be 20 degrees, this inclination will be 70 and the remaining left out inclination will be 20 degrees. So same inclination here, this angle shall be 20 degrees, this angle shall be 70 degrees. This is how we are supposed to resolve those particular force component. Once we have noted this particular force component, which has been placed on an inclined plane, 20 degrees taken into consideration. To this 20 degrees, this will be in opposite side. So this will be sine of 20, which is W sine of 20, and vertical force will be W cos of 20 degrees. So these are the force component parallel to x direction and parallel to y direction. These are the force component. Now to start with the solution, summation Fy is equal to 0. That is, we are going to add up forces parallel to y direction. If you show the forces along x and y axis, y component force is W cos of 20 degrees. X component force, which is towards the left hand side, is W sine of 20 degrees. And x component force further here, which will be on the upward direction, is F of F, and MA, which is nothing but in the upward direction. So these are the force component along the x and y direction. Now since we are adding up forces parallel to y direction, I will be considering all the forces parallel to y direction. Now as it is downward here, W cos 50 is downward. So I shall write it as minus W cos of 50 degrees. Then N is upward direction. So plus of N. N means what? It's a normal reaction perpendicular to the plane of contact. It will be in the upward direction. Plus of N. That is equal to 0. So N is equal to W cos of 50 degrees. Now W means what? 50 into 9.81. So substitute the value as 50 into 9.81 cos of 20 degrees. Cos of 20 degrees. Here it is 20 degrees, cos of 20 degrees. So W into cos of 20 degrees. So N is equal to, final value of N shall come out to 50 into 9.81 cos of 20 degrees. So we shall come out to 460.92. So these are nothing but the value of N, which is 460.92 Newton. Once you get the value of N, we need to find out the value of frictional force. Frictional force value is mu times of N. Mu value is 0.25, which has been given in the statement of the problem as 0.25. 0.25 times of 460.92. So F of F value shall be calculated as 0.25 into 460.92, and whose value will come out to 115.23 Newton. 115.23 Newton. So once we have calculated this, we need to find out the inertia force now. Inertia force is MA, and MA value is, M value is 50 kg into A. So we keep this as 50 into A as it is. So these are nothing but the values related to the direction of the x component force and y component force. Now we shall find out summation Fx term now. If we find out summation Fx term, I shall redraw this particular x and y axis. We had two force component here. This force component, x force component, was W sine of 20. Y force component is W cos of 20. And here this will be N, which is acting in the upward direction. Then apart from that, you also had two forces parallel to x direction. One force is F of F. Other force is MA, that is nothing but the inertia force. F of F value is been calculated as 115.23. So this value is substitute as 115.23, and this is 50 into A. So these are the two values that have been calculated, and we are going to make up what that is the forces parallel to x direction. So referring to this particular diagram, adding up all the forces parallel to x direction. So W sine 20 is downward, so minus W sine of 20 degrees, as it is towards the left hand side, so minus. F of F is towards the right hand side, plus MA is towards the right hand side, plus of MA, that is equal to 0. Further, we know the value of F of F. If we take this term on the right hand side, which is nothing but MA, keep it as it is, then this will be W sine of 20 minus F of F, which is nothing but the frictional force. Then W value is 50, so 50 into 9.81. W value is 50 into 9.81. W value is 50 into 9.81 sine of 20, first term, minus of F value is 115.23. That is nothing but the value of F of F. Then this is equals to MA. So reframing this equation, 50A is equal to, on the right hand side term will be 50 into 9.81 sine of 20 minus of 115.23, and whose value shall come out to 52.53. And A value shall be 52.53 divided by 50. and get the particular value as 1.05 meter per second square. This is what is the value of acceleration, that is A. Now with this particular acceleration value, we need to find out the distance traveled and the time taken to that particular velocity. That particular distance traveled will be calculated when the body is at rest. Body is at rest means initial velocity will be 0, and the body, we are going to calculate this distance traveled at a velocity of 15 meter per second. So for this, we are going to make use of v square. There are three equations for motion. V square is equal to u square plus 2as, v 2as, v is equal to u plus at, s is equal to ut plus half at square. So these are the three equations of motion that will be helpful to find out distance and the time interval. So making use of the first equation, v square is equal to u square plus 2as. So v square value 15 square plus is equal to initial velocity is 0 plus 2 into acceleration here shall be considered as positive because it is a case of an acceleration, not the retardation. If it had to be a case of retardation, you need to consider it as minus, or else you need to consider it as positive. And then s distance we need to find out, that is nothing but the distance traveled. S is distance traveled here. S is nothing but the distance traveled, which will be calculated in terms of meters. So reframing this equation, 15 square divided by 2 into 1.05 is equal to s. So s is equal to, we need to find out the distance now, which is 15 square divided by 2 into 1.05, and whose value shall come out to 107.14 meters. So this is what is the distance traveled, which is s is equal to 107.14. Now to reach this particular distance of 107.14, I need to check out how much is the time required with a velocity of 15 meter per second. With a velocity of 15 meter per second, how much time is required to cover a distance of 107.14. For that, I will be making use of the second equation, which is v is equal to u plus at. Certainly, you can make use of the second equation also. As we know the value of s, you can certainly find out the value of t also. So v is equal to 15, 0 plus a value is been 1.05, which you are going to consider it as positive because it's a case of acceleration. If it had to be a case of retardation, you are going to consider this to be a negative term into t. So t is equal to 15 divided by 1.05, which value will come out to 15 divided by 1.05. So whose value will be 14.29 seconds. So this is nothing but the value of t, which is 14.29 seconds. So this is how we are supposed to find out the value of s and t after when it has been subjected to a initial velocity, that is initial velocity as 0 and final velocity as 15 meter per second. We are supposed to calculate this particular value, and this is nothing but an example for kinematics. So this is when we use v is equal to u plus at. Supposing if we are supposed to use s is equal to ut plus half at square, the solution should come out same, or s is equal to ut plus half at square. So s is, I know, which has been calculated here, 107.14. Initial velocity is 0. Time will be automatically will come out to 0. Half a value has been calculated as 1.05. A value has been calculated as 1.05 t square. So whose t which shall come out to, t value shall come out to 1.107.14 multiplied by 2 divided by 1.05, and you need to take out the square root of this, whose value shall come out to 14.29 seconds. So whether you are going to use v is equal to ut or s is equal to ut plus half at square, the solution will come out same. This is how we are supposed to solve problem related to kinetics. That is nothing but an equation when it has been subjected to a inertia force. So if it had to be only a kinetic, if it had to be only a frictional force, block friction, in that situation inertia force will not come into picture. If it had to be an kinetics example, that means if you are supposed to find out final velocity or time interval or distance required, distance traveled after it has been subjected to a force or been subjected to a initial velocity. In that situation, inertia force needs to be considered. It is nothing but m into a. And inertia force will having two category, either an acceleration category or retardation category. When it is acceleration category, A will be considered as positive. When it is retardation category, A shall be considered as negative. And acceleration category, it will be opposite to the movement of the body. Retardation category, it will be towards the movement of the body. So this is how we are supposed to find out. This term will help you whether it is a case of acceleration or retardation. If final velocity is greater than initial velocity, acceleration. If final velocity is less than initial velocity, then it is a case of retardation. So this is how we are supposed to find out the solution related to kinetic friction. Thank you. Have a nice day.